Okay, everyone, I'm back with another video review, and just like the title says, I'll be doing my review of the Schiit Audio Bifrost MultiBit DAC. And before I get into this, I want to explain what the multi-bit marketing actually means. So, back in 2015, Schiit Audio released the Yggdrasil DAC, and the Yggdrasil was kind of a big thing at the time because most DACs that are out there are known as Delta Sigma DACs, whereas the Yggdrasil at the time was pretty much the only modern R-2R resistor ladder DAC that had been released in the audio realm. They've been around, the resistor ladder DACs have been around since the 80s and CD players and whatnot, but it's kind of phased out into the Delta Sigma IC chips instead. So things like the ESS 9018 DAC chip or the AKM AK4490 DAC chip have been very popular in today's modern era of audio electronics. And it was kind of a bold move for Schiit to announce a resistor ladder DAC. To give you guys an idea of a resistor ladder DAC, I had mentioned briefly in my unboxing video what it was like. But a resistor ladder DAC essentially just uses a bunch of resistors to do the digital to analog conversion. So this is kind of what's on the inside of the Schiit Audio multi-bit DACs, is that it's just a bunch of resistors in parallel, and basically as you input a digital signal, it'll be put into these resistor ladders, and then based on the voltage output, it can be amplified, and then that will be your analog signal. So to give you guys an understanding of how the R-2R DACs work, I'll briefly mention it in this video, but in comparison, a Delta Sigma DAC takes a digital signal. So I'll just give you guys an example here. So this is a binary input signal. So this might be from your computer, for example. So your computer will output this series of numbers, ones and zeros, as binary input, and that will be decoded from the DAC from a digital signal into an analog voltage waveform. And then that will be put into an amplifier, and then eventually you will hear that in your headphones or speakers. So the purpose of the DAC is to do the digital to analog conversion, and the Delta Sigma method uses a different topology compared to the multi-bit resistor ladder R-2R conversion. So a Delta Sigma actually takes your binary input, your digital input, it converts it into a lower bit actually. So it'll be, for in the case of ESS DACs, there'll be 3 to 4 bits. So it'll convert your 16-bit audio into 3 to 4 bits, and it will upsample very, very, very high up to the megahertz frequencies, and then it will use some DSP or digital signal processing to filter that and then bring it back into voltage conversion, and then that will be into your amplifier. Now that's different from an R-2R, because in R-2R it's very easy to take your binary input and spit it out into the R-2R resistor ladder, and then it will output some voltage. And it's very easy to calculate. So I'll give you guys an example here. So here I have a 16-bit binary input. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. Each of those numbers represents kind of one sample of your audio. So if you're listening to a CD, for example, you'll have 16-bit sampled at 44.1 kilohertz. And so for every second, you will get 44.1 thousand samples. Each sample is set at a certain bit depth, and that bit depth is determined by your binary input. So basically, you will spit out a binary input from your computer into the multi-bit DAC, and then your DAC will convert these ones and zeros, add them all up into a single voltage reading, and then for every second that you have your audio playing, it will do that 44.1 thousand times. So that's kind of like the basic overview of how the DAC actually works. And so I'll give you guys kind of a more in detailed look as to what this does. So this is the R-2R DAC. So as you have your input signal, your most significant bit gets put into the resistor ladder first. Typically, the most significant bits of your binary input require the most amount of precision, because if you think about a number, the most significant bit means that it's the most significant for the value. So let's just say, ignoring all of this, say you have a value of 1000. If you have a value that has a 20% difference between what it's actually supposed to be versus what it is. So if you have 1000 as your input signal and you get 20% of that is 800, that would not be good for your signal at all. So for a multi-bit DAC, usually the most precise resistors are set for the most significant bit so that the waveform is the most accurate. So as you have your binary input signal here, you will have your most significant bit usually on the left-hand side, and then you have your least significant bits on the right-hand side. So as your binary input signal gets outputted from your computer into the resistor ladder, it will actually go into this network here. And so I've kind of notated this as 2RP for precision. So the most significant bits get put into here, and they require the most precise resistors. So I'm just representing these 4 sections here as the 4 sections that require the most amount of precision. So these are precision resistors here. So as your input signal gets put into here, basically each binary number that you put into the system corresponds to a switch in the actual multi-bit DAC. And so for every time you put a signal in there, it'll go into each slot of the 16-bit DAC in this case. So in this case, you have a 1 on the left-hand side, the most significant bit. So in this switch, it's actually closed. So you have a 2R and 2R here, and this circuit here gets closed. Same thing with bits number 2 and 3. 2 and 3 both have closed gates there, so they are connected to the reference voltage there. So as these are closed, that means signals going through the actual resistor into the amplifier. And in the case of the 4th bit, which is a 0, on the case when the input is nothing, it will go off to the off switch. So it's just connected to ground and not connected to the reference voltage. And so you can do that for every input from the binary signal. So 111011001100111010 corresponds to 11101100111010. And so that's how the input of the multi-bit DAC works for a resistor ladder. To calculate this, it's actually pretty easy. So there's a series of resistors here, so 2R and 2R there. So if you have your voltage coming in through here, this is just a voltage divider, so it's your voltage divided in half. And then, so this is one section, here's another section, here's another section, etc., etc. So there's 16 sections, each one corresponds to each binary input value. And so for each one, you can kind of split it up into the section, and you can calculate that section based on the voltage from the previous section and the resistors from there. So if you were to look at the resistors here, in this case, you have a 2R and a 2R, so your voltage gets divided in half. So Thevenin's equivalent in terms of electronics is that if you have 2 resistors, even if they're a different value, and the voltage, it's equal to this corresponding circuit. So it's the resistor with the voltage divided in half and the voltage, the corresponding new voltage. So this would be the voltage divided by 2, because if this is the case of here of 2R and 2R, so 2R, 2R, your voltage gets divided in 2. So you'll have V1 divided by 2 here in this case. And then your corresponding resistor will be 2R divided by 2, which is just R. So you'll get this circuit actually. So you have your next kind of circuit here, your next channel. So you'll have your 2R here, 2R there, and your single R up here, and your single R there, and the equivalent, Thevenin's equivalent from the previous circuit. So you'll have your R there and the voltage there. So it becomes 2R in this case, because resistors put into series are just added together to get your value of resistance. So that's 2R. So 2R and 2R and your voltage, you basically get a second voltage divider. And this can repeat for the entire ladder sequence. So every time you see the R and 2R, that is basically this sequence. You just divide your voltage in half and half and half and half and half and half, etc. And then if all of these switches are on, which means everything is 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1, that means all the switches are active, and that means all the voltages from the reference value will be put into this amplifier, and that will be your signal. So that in this case would mean that your audio input signal, for example, has the maximum bit depth. And so of a binary input signal of 16-bit, typical CD quality audio, you'll have 2 to the 16 values of binary numbers that you can input. So you'll have a total of 65,536 actual values that your DAC can output from this circuit. Pretty interesting. If you want to add all this up, you can basically sum it up in this notation here. So the voltage output into your amplifier will equal the reference voltage from your input there. And you're summing up basically every single section of this R-2R circuit. And so you'll have basically, if we were to do the first one, for example, where your most significant bit is 1, so it'll be 2 to the n, so n is 1, or 0 in this case, so 2 to the 0 is just 1, so 2 to 0 is just 2, so your voltage of that bit, which is bit 0, the most significant bit, so that voltage will be 1, because it's on or off. So this is on, and then you'll just divide that by 2, and then you add up the other ones. And if the other ones are all 0, then your output voltage is just your reference voltage divided by 2. Very easy. So that is kind of the overview of how the multi-bit technology works. In the case of Schiit's products, they now have a total of 4 or 5 different multi-bit DACs out there. So there's the Yggdrasil, the Gunnar multi-bit, the Bifrost multi-bit, their newest one, the Jotunheim multi-bit, and the MultiBit multi-bit. Each one kind of has their own name. Like in this case, this is called the BiMB, Bifrost multi-bit. For Gunnar, it's Gumby, Gunnar multi-bit. For Iggy, it's just Iggy. For the MultiBit multi-bit, it's the MultiBit multi-bit. And I guess now with the Jotunheim, it's Jotunheim multi-bit. So they've been, the community's kind of given the multi-bit DACs their own name, I guess. Pretty interesting. But anyway, talking about the Bifrost multi-bit, my impressions are going to be pretty interesting because I haven't really had another DAC that uses something other than Delta Sigma. So it's been really interesting to compare the multi-bit module of this DAC compared to a Delta Sigma DAC. And so from my experience, I do believe the multi-bit DACs have a kind of different sound signature than the Delta Sigma DACs. You'll often see this in online discussions, but I like to compare the multi-bit sound to a tube amp kind of sound, whereas the Delta Sigma DACs have more of a digital kind of sound. So if you're familiar with that terminology, that kind of sums up how the multi-bit DACs sound. For those of you who are not familiar with the comparison between solid state and tubes applied to, in this case, multi-bit versus Delta Sigma, basically it'll have kind of a warm sound signature, so it's a little bit tilted clockwise from the reference of what I would consider neutral. So some people give that term kind of a lush, organic, natural kind of sound. So you'll kind of hear that terminology used when describing the multi-bit DACs that Schiit Audio makes. Compared to a Delta Sigma, which is kind of more flat. Maybe some people describe it as cold sounding, so it's a little bit tilted counterclockwise, so it's lacking a little bass and it's a little bit treble heavy. So some people describe solid state DACs, or not solid state DACs, Delta Sigma DACs as kind of cold or analytical, harsh, glary, grainy kind of sound. For me personally, comparing the MultiBit Bifrost to other DACs out there, mostly Delta Sigma, I've kind of had the same experience, is that I find the MultiBit DACs to sound kind of warm, and what's different for me is definitely the ability for the MultiBit DACs to image versus the Delta Sigma DACs that I've compared them to. So I'd like to describe the soundstage of the MultiBit DACs as being more depth-based. So if you're comparing a Delta Sigma, it's kind of flat and wide, not very deep in terms of the depth of the soundstage. So you get this kind of limited view of how images are placed around your head, whereas in a MultiBit DAC, in the case of the Bifrost MultiBit, it seems to kind of round the soundstage more, so you don't get as much left and right imaging. You get kind of a curved imaging instead, so you have more depth in terms of the soundstage, which is interesting to see. Well, not really see, but to hear, because it actually sounds really nice for a lot of types of genres of music, such as orchestral or soundtrack, or anything that has natural instruments placed in the soundstage. So binaural actually sounds pretty nice. However, I find that the imaging within a soundstage is not exact. I find Delta Sigmas to be more exact in that matter. When listening to my own binaural recordings, I usually have like hard left and hard right sounds. If you're listening to it on the MultiBit DACs, it tends to push those sounds closer to the front of me. So instead of being a hard left, it's more like 30 degrees from the horizontal line, or on the right, it's like 30 degrees from that side. So it seems to push the sounds more inward in comparison to Delta Sigma DACs. So my preference is more of a natural, neutral sound, and for me, the Delta Sigmas have a more accurate imaging in that regard. But for music listening, I can understand why a lot of people really like the MultiBit DACs and why it kind of sounds natural, whereas in the Delta Sigma, it's more flat. In the MultiBit, it's kind of tilted inwards, so it's kind of like listening to speakers. So that's kind of a strong point for the MultiBit DACs. Last week, I actually went to the Schiitr, and that was a cool experience. I got to compare the Bifrost MultiBit with the Bifrost normal one, the Delta Sigma one, which happens to have the AK4490 DAC chip in there. To be honest, I actually preferred the Delta Sigma version more. I just found it to have more detail on top. It sounded more crisp in terms of where the images were. It didn't quite have the same depth of imaging as the MultiBit version did, as I had mentioned before. And the overall tonality seemed more accurate to me on the Delta Sigma version, whereas on the MultiBit version, it did sound a bit warm and kind of tubey sounding, if you can understand where that's coming from. So for me, I preferred the Delta Sigma version of the Modi, or not the Modi, of the Bifrost. However, speaking of the Modi, I did compare the Bifrost MultiBit with the Modi MultiBit, which is $250 versus $599 of the Bifrost MultiBit. So it's a huge difference in price. If you want to get an experience of what the MultiBit sound is like, I would actually recommend getting the Modi MultiBit over the Bifrost MultiBit, just because this is such a big investment. To me, comparing the Modi MultiBit, which is actually the same module used in the Jotunheim MultiBit, so the two DAC cards are comparable. To me, comparing the Jotunheim MultiBit to the Bifrost MultiBit, the difference was actually very small. You do get a little bit more crisper images of the Bifrost MultiBit, and the top end does seem more refined in the treble section compared to the Jotunheim MultiBit, but overall the quality is very similar, and I was actually very surprised at how similar they sounded, given that their price is actually way different. So if you're interested in giving the multi-bit technology a test, I would definitely recommend the Modi multi-bit over the Bifrost multi-bit. I did not compare the Bifrost multi-bit to the Gunnar multi-bit, but I have heard the Yggdrasil before, and that's a totally different beast in terms of its overall sound. It does have some of the very similar qualities of a multi-bit DAC that the Bifrost multi-bit has. So what I described for the Bifrost multi-bit can be applied for the Yggdrasil, but the Yggdrasil just does things a lot better compared to the Bifrost multi-bit. And so when I compared the items at the Schiitr, I was using the USB input, and this version that I have with me has the USB Gen 2 USB board, whereas the one at the Schiitr had the USB Gen 5, which is their newest one. So it wasn't quite a fair comparison between the multi-bit versions and how that compares to the AK4490 DAC chip, the regular Delta Sigma version. So it's not quite an exact comparison, but from that experience I got that the Modi multi-bit and the Bifrost multi-bit sound very similar. So even if the differences between the USB input was better on the Modi multi-bit, to me the experience was pretty positive in that if you want to get the multi-bit sound a try, you can give it to the Modi multi-bit instead of the Bifrost multi-bit. I have been comparing at home the Modi multi-bit with my LH Labs PulseX Infinity, which is a Delta Sigma DAC, and I've been using the Schiitr, which converts a USB digital signal into a coaxial digital output. And so I've been using coax output into the Bifrost multi-bit compared to the LH Labs PulseX Infinity coax input, because I know LH Labs has a slightly different approach for how to use the USB signal versus Schiit. And so I wanted to make a more fair comparison between the two. And I still prefer the LH Labs PulseX Infinity over the Bifrost multi-bit. So that's my preference in sound. I prefer the imaging, the more precise imaging of the LH Labs PulseX Infinity over the kind of more musical sounding Bifrost multi-bit. But a lot of people who listen to music just want it to sound good, and I do agree that the Bifrost multi-bit just sounds good for music. It's not necessarily a bad versus good thing. It's more of a flavor preference, just like tubes versus solid state amps. Some people really prefer the tube sound, some people really prefer solid state sound. So it's really up to you in terms of the sound that you prefer. So for me, it's hard to recommend the Bifrost multi-bit for now, just because the Modi multi-bit sounded very similar to this at a fraction of the cost. And so if you want to get a flavor of the multi-bit sound that Schiit offers, I would definitely recommend that again. In terms of how the Bifrost multi-bit works, it's really simple. On the front here, you just have the logo, the source input switch, and you can see there'll be LEDs for the different inputs. So you'll have USB, Toslink, and coaxial inputs. And then on the back, it's really easy to use as well. So you have your single-ended RCA outputs, and that's the only output it has. For inputs, you have the coaxial RCA input, USB-B input, and the Toslink optical input. Over here, you just have the AC power input and the power switch over there. And if you're wondering why I have this blue tape on the front here, it's because the lights actually get super bright. It's insane. So I'll plug this in, actually. I'll turn on the power, and you'll see the lights go on and off there. Try and get the camera to focus. It's hard to focus on this aluminum. Let's get the logo. But these lights are actually super bright. It's hard to see it. The camera doesn't do it justice. If you're in the dark, these lights are super bright, and so that's why I put this sticker, this blue painter's tape on there, just to dim it a lot. So that's really the only downside I have for the actual unit. If you're familiar with Schiit's products, they tend to have kind of the same build quality, so it's a very solid construction. I believe this is just a U-bent piece of steel, so it's actually a very solid piece of equipment, and yeah, very durable feeling. It's very heavy. Schiit weighed this as 5 pounds, so it's quite a heavy unit just for a DAC. If you're familiar with Schiit's amplifiers, they tend to get super hot. For whatever reason, they're run class A, so it's on full 24/7, but they get super hot. And so coming from a person who doesn't own any Schiit products, I was expecting this product to be super hot as well. It actually barely gets even warm, so that's a good thing for Schiit. I was expecting this to be super hot, and originally when I got this, I didn't stack anything on top of it because of that, but it doesn't get warm at all, so it's completely pretty much just room temperature. So that's good for a Schiit product. So yeah, that's kind of my overview of the Schiit Audio Bifrost MultiBit. It sounds good, but it's not kind of my flavor of sound in terms of what I like to listen to. If you want to get kind of a taste of how this sounds, you can get the Modi MultiBit instead, which is $249 from Schiit's website. It's a lot similar in terms of sound than you would think, given the price difference. But yeah, that was my experience between the Schiit MultiBits in general, is that as you go from the Bifrost MultiBit to the Yggdrasil, it's a huge kind of difference in sound, but it has similar characteristics. So if you're looking for similar characteristic DAC, again, the Modi MultiBit would be your go-to for that. So yeah, those are my impressions. If you guys have any questions about this, feel free to leave a comment below. Otherwise, thank you so much for watching, and I hope to see you guys soon.